So today we're going to talk about constant speed, and we are going to do a constant speed lab. Constant speed is where something is moving at the same rate of speed continuously over time. And so in this lab I have 3 videos that I am going to share with you today, and you will see a constant velocity car that is traveling over a 5-meter track, and we are going to calculate its speed by looking at the time it takes to get to each meter mark. And so you will need a timer for this particular lab today. It should be the only extra material that you need other than a printout of your lab. You will probably want to do this lab on paper, so you will want to print it out. It will be a lot easier for you to look at the data and then also to draw the graph that you'll need to draw on the end. And so on your timer, you can use the timer that is on your cell phone. You can also use a timer that is on your computer, but you do want it to be counting up and you want it in seconds. Okay, so in your paper, you are going to see this little data and observations chart. And so this is where we are going to record the data that we get from our 3 videos that we're going to watch with our constant velocity car. And so what you're going to see is that we have a track that consists of 5 meters, and I have measured this off using red tape. And so on the ground you're going to see some red tape markings, and every time we see a piece of red tape, that means that we've gone another meter. So in the video you are going to start your timer when the constant velocity car passes the nose of it passes the start line, and then you're going to hit the lap button on your stopwatch or timer when it crosses the next meter line, and you're going to continue to do that for 5 meters, and then you will go ahead and stop your timer. Once you have done that, you're going to write down your data. So for example, in trial 1, if I have my data is 0, 2, 4, 6, 8, 10. That's what I would write down. But you are likely going to have this in seconds, so it might be like 2.22 or 4.80. Okay, so you're going to want to write down whatever time you get for each meter marking in your trial, and then you're going to notice that we are going to do this 3 times. The reason that we do this 3 times is because we don't ever want to just trust the data for one sample. We want to do multiple samples, and then we are going to find the overall average from those samples to get the best data possible. And so I have included 3 videos that we are about to watch, and you will record your times for each video. You may need to reset your timer and reset the video and re-watch it and retime, and it might take you a couple of times to get the hang of pressing start and then hitting the lap button 5 times to make sure that you have the most accurate data. Okay, so we're going to start with the first video. And I'll kind of walk you through this first one so that you know when to hit start and then when you need to hit your lap button. Start, lap, 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 stop. Okay, so now you're going to take your numbers that you have on your phone or your computer, and you are going to record those right here for trial 1. Okay, so once you are finished recording your data, we're going to do the exact same thing with the second video. Start, lap, 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 stop. Okay, so in this video you should notice that the constant velocity car is kind of veering off to an angle. This is very common with our constant velocity cars. It's very hard to keep it on a straight path, and so that is one of the reasons why we do 3 trials versus just one, because we are going to slightly have different numbers, and so we want to have an average to get the best data possible. And so you're going to record your data right here on trial 2. Remember, 0 for your distance should be 0. That should be 0 all the way across. And then you're going to write down your new data for 1 meter, 2 meter, 3 meter, 4 meter, and 5 meter. Okay, so now we are going to look at our last video, and we're going to do the same thing that we've been doing. Start, lap, 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 stop. Okay, so you're going to take your final numbers and you're going to put it right here where we see trial 3. And then what you want to do once you have that is you want to find the average going all the way across your line. So for example, if I had the numbers for 1 meter, 2, 2, and 2, to find the average of that, I would do 2 plus 2 plus 2, which equals 6, and then I'm going to divide that by 3 because I have 3 data points. So 3 divided by 6 equals 2. So my average right here would be 2. Again, remember you are going to have a decimal more than likely for your average time because your trial 1, 2, and 3 probably will have a decimal as well. When we look at decimals, we round out to the nearest hundredth place. So 2.865 would equal 2.87. So this would be rounding it to the nearest hundredth place. Okay, so I want you to go ahead and find your average times for the 1 meter, 2 meters, 3 meters, 4 meters, and then 5 meters, and then that's going to be the data that we're going to use for the remainder of this particular lab. Okay, so now you should have your data for your average times. And so what we're going to do is we're going to plot that on our graph. And so before we do that, we need to kind of set up our graph. And so what I want you to do is I want you to skip a line, and then you're going to mark 1, skip a line, 2, skip a line, 3, and I'm going to keep skipping a line and counting up, going all the way across, so you can see that I'm modeling that on my paper. Remember, it will be a lot easier for you if you have printed out this lab for you to draw this graph, okay? So you should be able to go all the way to 14 on your graph. And then what we're going to do is we're going to take our distance and we are going to take the time that we have for our average time, and we're going to plot that on our graph, okay? So go ahead and get your graph set up, and then we're going to go ahead and plot our data. All right, so you should have your graph set up now, and you should have your data ready to transfer it onto your graph. And so I'm going to just set mine up again real quick. All right, so you're going to take your distance, and so let's say our first distance, remember, was 0. Our time should have been 0, so I'm going to put a dot there. And so let's say for 1 meter, I had an average of 2 seconds. So I am going to put my dot right there. And for 2 meters, let's say I had an average time of 4 seconds. So I'm going to put my dot there. Remember, this is just an example that I am showing you. Your data is going to be quite different than mine. And so you want to make sure that you are using your data set, okay? So let's say for 3 meters, I had 6 seconds. So right there. Okay, and then for 4, I had 8 seconds. And then for 5 meters, let's say I had 10 seconds. So once you're done, your graph should look pretty similar in nature to mine. What you're going to do is you're going to take another piece of paper or a ruler and you're going to find your best fit line. So a best fit line should be a straight line. Not all of your dots will necessarily touch that line, but it should be pretty close. And so once you have your graph, it should look pretty similar to this, where you have a diagonal straight line. And this line represents constant speed. So anytime I have a diagonally straight line on a distance time graph, that means that I am traveling at a constant rate of speed. Okay, so take a moment and get your graph going. It should use your own data, but it should look pretty similar to the one that I have created here. And once you've done that, you're going to hit play again, and we are going to move on to the last step of our lab, which is to calculate the speed. And so when we're calculating speed, we're going to take our distance and we're going to take the time. So let's say my distance equaled 1 meter and my time equaled 2 seconds. So to calculate that, I'm going to do distance divided by time. Okay, and that is going to give me my speed. And so distance divided by time would be 1 divided by 2, and that's going to give me 0.5. Again, remember, we do go out to the hundredths place if it's needed. So for this one, that would be 0.50. Okay, there is another video in this folder on calculating speed. It's devoted just to calculating speed. So if you're needing a little bit of extra instruction on calculating speed, please go ahead and close out and move on to that next video so that you can watch that. You are going to calculate the speed for all 5 meters. And then you're going to use those calculations to answer some of the questions that you see in the remainder of your lab. Once you have completed your lab, you are going to upload it, whether that's a picture. If you've done it on your computer, you can just submit it that way as well, and you can email it to me or submit it through Schoology. If you have questions, please let me know.